Hey, everyone, thank you for joining us today in this elite podcast. I have the privilege of being with Francois Carl and also Dr. Samuel Fortin. And I know that my pronunciation is a bit off, so you're going to have to bear with me, Dr. Samuel. But nonetheless, it's such a pleasure to be with these gentlemen. And one of the key goals for this particular podcast, which will consist of a series of episodes, is to introduce to you a highly credible, well-researched omega-3 fatty acids and other nutraceutical compounds that these gentlemen have been able to kind of put together into formulations that I think can be game changers in your practices, helping you in your protocols with your patients and your clients. But before we focus on all of the applications and how you can use these in your clinics, we need to start with the foundations and look at how this all came to be. Now, I've had the privilege of being involved with other nutraceutical companies and learning how they are effectively put together, but I have found some unique pieces that are a point of difference for what they will present to you. There's a lot of credibility, research and development, and also ongoing research that I think puts this up at a much higher level of credibility, trust, or something that you can incorporate into your practice. And so without further ado, I'm going to just introduce Francois Carl. We've had some former work experience together, but I know that your experience goes for many years in the nutraceutical industry, in the natural products industry. Could you talk about that and what your passions are in this industry and what led to the co-founding of this particular company?
Yeah, no, thanks, Mike. It's been a while. I've been in the industry for more than probably 18 years now and counting. Got a master's degree in organic chemistry. My first initial role in the industry was quality assurance manager. And from there, I tackled regulatory affairs and then research and development and product development, which is where I met Dr. Fortin. And while I was researching or looking for different technologies and ingredients to incorporate in our company at the time, which was a company that specialty was in essential fatty acids. And one of my roles in that company back in the days was also to do some product development for other branded companies in North America, well-known companies that you can find in different retail stores and grocery stores, but also in different channels like the practitioner channels. So I had a chance to develop many different formulas, mostly oil-based formulas. That pretty much the core of my expertise when it comes to the science of looking at different dietary ingredients. So fish oils, marine oils, which includes krill oil and other types of marine species extracts. And then, of course, like lots of different extracts that would come and have synergetic effects or combinational effects with omega-3s. And so obviously seed oils and all that. So developing products like in soft gels, liquid formulas. And so 18 years and different companies, where the first one was called Biojoga. This is a company that myself and my partners sold to Neptune Wellness, which is where I met you. And we worked together for a short while. And then in that company, I had different roles, including marketing and operational as well, taking care of the whole operation, building supply chains. We had the chance to touch on CBD at one point, which was really interesting, building that supply chain in North America, US mostly. And then eventually I decided to take off in a new adventure in a company called High Five Health Group, which we founded, myself and my co-founders, and in which we launched a brand called Evidence-Based Supplements, EB Supplements, where we introduced the MAG-O3 technology, which is really to try to educate the industry, but also obviously the consumers on this amazing omega-3 based technology, which Dr. Fortin invented, has the patent estate for which we have access to. So that's pretty much it. Yeah, I wouldn't know what to add to that, Mike.
Well, and I'm glad you addressed that. I mean, given your vast experience with oils, as you had mentioned, all these years that you have just done this deep dive and then some into the seed oils, marine oils, etc. What I'm excited about in this conversation is to learn more and help these practitioners understand better how you've been able to develop this cutting edge products, which consist of oils, and how they stand apart, given it's a vast world out there in terms of what products have came about that have seed oils and fish oils, marine oils, whether it's krill or algae or whatever it is. And you've gone leaps and bounds, above and beyond that. And so I'm excited to both learn from you and from Dr. 14 about this, given your High Five Health group that you have innovated. I mean, this is what's really exciting for me.
Well, the only thing I'll add to this, Mike, is even after 18 years and of reading all the scientific journals and learning about omega-3s and fatty acids and oils, and it's incredible how every day I learn something new. And that's what happened when I met Dr. Fortin. We started to talk about his technology and what he was researching. I just couldn't believe that this whole realm of science existed. And from that point on, I personally invested a lot of time and effort to help Dr. Fortin develop this technology by working with him on multiple clinical trials. But just to say that it's just incredible how we keep learning, even though we feel we've learned so much already, right? But there's always something new that you can learn about. So that's just really exciting.
Yeah, people are excited. Practitioners are excited about healthy fats and how they can incorporate those into their protocols. And I know that your group and your supplements go beyond just oils, of course, as it gets into other nutraceutical compounds. But in that particular segment of nutraceuticals, the healthy fats, the oils, there are some concerns about rancidity or, what, and I know we're going to do a deeper dive as this conversation progress. So hopefully we can debunk some of the myths that are out there or help address some of those objections and those concerns that practitioners have. Because, keep in mind, some MDs, chiropractors, licensed acupuncturists, health coaches, they have abstained from carrying omega-3 fatty acid formulas in their clinic because they're weary of the fact that they've gone through all these levels of processing. And so they're no longer of value to the patient. I know I'm probably getting too far ahead here, but that is one concern that has just been heightened recently. But I know that in our conversation, we'll be able to address that concern, that objection, and hopefully put that at ease because there is value. And I know that you have meticulously been able to overcome that, and that there is tremendous value in these particular products that will in turn help patients with heart health, with brain health, and so on, so that they can have that rest assurance in the protocols that they use. So, without further ado, I do want to introduce you appropriately, Dr. 14. You've been a PhD over the past 20 years. Is that correct?
Yeah. So basically, I was born and raised near the St. Lawrence River. When I was very young, my mother always, put me some fresh salmon and shellfish on my plate. And one of the theory that we have is that the human species have evolved with a big brain because they are raised near the ocean, because they have access to nutrients like omega-3 fatty acid, and it's easy to collect. It's really easy to collect. You can go to walk, near the St. Lawrence River and came back with a lot of treasure and you can eat. That's the thing that would tint my research. So I did my PhD, was in pharmaceutical chemistry. So really, really strong organic chemistry, synthesis. All the natural product was a template for doing more synthetic molecules. So a kind of humility that you spend 4 years in the lab trying to have 1 milligrams of this compound, and in the nature, the nature just synthesize them every day. After this, I spent maybe 1 or 2 years in Montreal on a standard pharmaceutical company, on cancer research. So all my intern and my first job was on cancer, on a BCL2 inhibitor, so inducer of apoptosis. Cancer cells, it was always on my mind, and it's still on my lab. I always have 1 or 2 cell lines on the incubator just to try to kill them with some natural molecule. After this, I came back to add a position as a head scientist on the Marine Research Biotechnology Center. And I was appointed associated professor at the small university, Quebec, Rimouski, UQAR. That's where is my lab here presently. The first project that we have is to look at the St. Lawrence River, because we have a lot of fisheries and they have a lot of byproducts. So the first project that was involved is to build a molecular library of extract from all the byproduct of the fishery of the St. Lawrence River. And one of these fraction that we collected in the byproduct of, if I remember well, it's mackerel, it's a fatty fish, was an extraction, and the extract was rich in omega-3 fatty acids. And it's all began my journey of the omega-3 fatty acids.
You know, there's so much there, and I appreciate you sharing that. When it comes to the vast cancer research that you've been involved in and what that represents, the fact that there is that level of research and experience in terms of how these oils can impact people's lives, it's a big deal. It's often become underutilized in terms of what marine oils can accomplish across the board, given all of the many concerns, whether it is somebody who has cancer or other conditions that they're struggling with. These can actually have their place. So let's go ahead and get started with just giving us a brief introduction to MAG-O3. What is it?
So basically, MAG-O3, it's for omega-3 monoglycerides. So basically, I refer it at maybe the fourth generation of omega-3 fatty acids on the market. At the beginning, there's a regular oil, let's say cod liver oil, or the oil I just extracted from the byproduct of the mackerel. So it's a triglyceride. It's a natural form of all the lipids. So it's 3 fatty acids that bind a glycerol backbone, but it's not really concentrated in omega-3 fatty acid. Typically, it's about 20 to 30% omega-3 fatty acid. After this, we saw concentrated fatty acid. So to concentrate the fatty acid, you have to cut down the glycerol and re-esterify it with ethanol and distill it. So it's the second generation ethyl ester. After this, the third generation, it's to take the concentrated ethyl ester and re-esterify back to triglyceride. We call it re-esterified triglyceride. And our monoglyceride, I think it's the fourth generation. So basically, instead of converting back to triglyceride, we stop to the monoglyceride form. So it's one fatty acid to one glycerol molecule. And this chemistry makes the molecule very, very unique because it's a non-ionic molecule with a polar head, the glycerol, and a non-polar tail, the fatty acid. And this physical chemical property that make the monoglyceride very, very, very unique. They have a plenty of good things that we can do with monoglyceride. And just for example, seed oil monoglyceride are currently used in the food industry and are the most used emulsifying agent on the market. So it's a well-known molecule, but with omega-3 fatty acid, it was the first time. And that's why we got the patent. It's the first time that someone isolated and worked with the SN1 monoglyceride.
And before this was isolated and this came about, what prompted this in the first place? What led to this discovery of the MAG-O3?
I had this oily fraction from mackerel in my lab, and I have some cancer cells that grow in the aqueous media, so in water, and the two didn't mix. So it was impossible to me to solubilize the oil on the media culture for the cancer cell, to try to kill the cancer cell. So I said, let's do an hydrolysis. So I will hydrolyze the triglyceride to free fatty acid, and the free fatty acid will be, water soluble, and I will be able to test the fatty acid profile of the oil. So basically the reaction didn't come to the end. So it's ended up with a mixture of free fatty acids and monoglyceride. And it's turned out that the monoglyceride was the better, form to kill the cancer cells. So we did kill all the cancer cells, and it was beyond expectation. I came back to the extract that I put in on the culture, isolate the molecule, put it on the HPLC-MS, and saw that there's a monoglyceride form. So that's the genesis of the monoglyceride.
So given this genesis phase of the monoglyceride and this SM1, where you were able to kill cancer cells, was that part of this exploratory cancer research?
At the time at the research center, we got financial support from the ASEC. It's an Association for Cancer here in Rimouski. So they say, okay, you have to work on cancer cells. So we screened a lot of extract that we made from the fishery byproduct on 4 cancer cells. We have breast cancer, colon cancer, prostate cancer, and colon cancer. And the other part was inflammation. So we got the white blood cells that we can stimulate an inflammatory response. So at the time, we screened a lot of molecule, a lot of extract. And the point was to start with a crude extract, if the crude extract can kill cancer cell, I go back to the lab, try to separate the compound, test all the subfraction, and look at the activity only on the fraction, and going back to this fraction, try to isolate the molecule. It's called bioassay guided fractionation. Sometimes it's impossible to find the molecule. It's a synergy between all molecules. And at some time, like the monoglyceride, we came up at the end with 3 molecules, EPA, DPA, and DHA monoglyceride. The activity was really nice to kill cancer, better than the free fatty acid. And all this work is published, and we are able to tell that the monoglyceride is more potent than the free fatty acid to induce apoptosis, so to kill cancer cell lines. So it's not just the EPA or the DHA. It's the molecule itself that it's better absorbed by the cells and probably goes to the mitochondria on a pathway. But let's talk about mitochondria another day. So
yeah, definitely mitochondria is definitely a topic of interest for sure. We can delve into that at a later time. Often omega fatty acids are looked at to help with heart health, but I know it goes way beyond that. And what I'm hearing you say is that specific cancers, colon, prostate, and others is what was explored here and where you've been able to perform this research. And it really is eye-opening as to the different categories of protocols where this product could be incorporated. So with that being said, clinicians are confronted with marketing of other professional lines, other supplement lines where there often are omega fatty acid products. And whether it is plant seed oils or marine oils, many clinicians see the value of how omega-3s can help their patients. And there are many omega-3 products out there. Can you explain how MAG-O3 sets itself apart as an omega-3 fish oil?
First of all, it is the next generation, so it's the one that it's better absorbed. So we have several clinical trials comparing the ethyl ester or the RTG, the 2 main forms that are currently available on the market, and we got a better absorption with monoglyceride. This was confirmed by an early clinical trial that we performed with the University of Sherbrooke on a cystic fibrosis patient. Cystic fibrosis patients are, the worst case that we can find at the time because it's impossible for those people to digest and absorb fat without supplementing with enzyme because they have some obstruction on the pancreatic and there is no lipase naturally deliver on the digestive tract. So they have to take enzyme. Each time they go eat, they took enzyme to make sure that the fatty acids are broken down and all the nutrients. So we asked them at bedtime, just before going to sleep, don't take any enzyme and take our monoglyceride just to see if it's possible by itself to be absorbed without anything on the digestive tract. And we found that, yes, the monoglyceride can be just absorbed as is on a patient that cannot digest fat. So this is the extreme. So whatever the digestion, it's, impaired by something, age, inflammation, or whatever it is, the monoglyceride can be absorbed directly to the bloodstream. No need to digestion. Ethyl ester and RTG, you need to digest them to be absorbed. And if you go at the higher doses, there is a saturation in absorption with triglyceride and ethyl ester. At some point, too much oil, not enough enzyme and everything, and it just goes through. Monoglyceride, we didn't see any limitation of absorption, whatever the doses you take. So it's the main property of the monoglyceride, and it don't need anything to be absorbed. So it's a pre-digested oil.
So one of the main reasons for working with cystic fibrosis patients was because they're deficient in lipase. They have difficulty breaking down and digesting fats. Is that why you had worked with cystic fibrosis patients?
Yeah, exactly. Because they cannot digest fat. They have to be supplemented with enzyme. So without any enzyme, it was the perfect model for us, human model, because you can go with mice, rats, and everything, but it's not the same. It's really difficult to have a good in vivo model for lipid absorption. So we want to target the human health. So we choose the model that the disease in the human that are the worst to absorb fat, and it was cystic fibrosis. And all the studies published, and we got a wonderful result. And with this supplementation, we are able to correct the imbalance because cystic fibrosis patients are prone to inflammation because there's an imbalance between arachidonic acid and DHA. So arachidonic acid, it's a pro-inflammatory fatty acid, and DHA, it's inflammatory resolution. So you have to have a balance on it. But cystic fibrosis patients have too much of arachidonic acid because they cannot absorb well the omega-3 fatty acid. So we are able to correct the imbalance on those patients.
And although cystic fibrosis patients have that arachidonic acid imbalance, I can only imagine that there are people in other categories that do not have cystic fibrosis that also have imbalances where this oil or this could be beneficial.
Yeah, of course. Yeah. Most of the people, the only way to have a correct balance on omega-3 and omega-6 is to live near the ocean, maybe 2,000 years ago, because all the food, it came from the sea. Right now, even in Rimouski, we test the omega-3 index and volunteer near here. It's a little bit higher than the rest of the country, but definitely there's not enough omega-3 fatty acid in our food right now. It's impossible to get enough. You have to go take supplements. Or you can go and try to eat fish maybe 5, 6, 7 times a week. But there's publication showing that even if you take 3 or 4 fish meal per week, it's not enough to reach the desired omega-3 index. So you have to supplement yourself with omega-3. So I think MAG-O3 is the most efficient way because there is no waste. All the fatty acid you took on your soft gels go right through to your bloodstream because it's already been hydrolyzed and it's just absorbed by itself. So it's the best way. Right now, it's the best way to get your omega-3 fatty acid. It's with MAG-O3.
One of the concepts that I want to understand better, if you can kind of walk through this with me, is how blending well with water can affect MAG-O3's functionality within the digestive system.
Frank, I think you made a beautiful experiment.
Yeah, no, I know we definitely made an experiment a while back. Absolutely. The experiment that Sam is referring to is we took MAG-O3 and we added astaxanthin, which is a great colorant. So it colors the oil, it gives it an orange and reddish color. And we did the same thing with the triglyceride oils and then just added it to water just to see how well both oil would blend. So we knew that the triglyceride, the anchovy sardine oil, wouldn't blend at all with water. It's 100% oil. But MAG-O3 oil was surprisingly pretty much miscible in water, which means that it mixes with water pretty well, which is really due to the presence of monoglyceride, which is an emulsifier. So it acts really much like a soap would, right? It's a molecule that likes oil, but also likes water. So it feels pretty comfortable in both medium. So that's what monoglyceride, that's one of the key characteristics or properties of MAG-O3 is it's those monoglyceride omega-3s or fatty acids that are present in the oil. The fact that they also like water, it basically helps the MAG-O3 oil integrate an aqueous environment. So when you take a look at the digestive system, gastric fluid, intestinal fluids, it's all composed of water. It's an aqueous environment. So when you introduce an oil isn't like water, so it basically has a hard time integrating those environments. So your body found ways to facilitate the integration of such molecules in your body. So like, for instance, you'll produce bile salts, which will come and emulsify fatty molecules or liposoluble molecules. It'll facilitate their integration in your body by emulsifying those molecules so that they can be integrated into your gastric fluid, your intestinal fluids, where you'll find all the enzymes that are necessary to break down those nutrients so that you can properly absorb them. But and fish oil is one of them, right? Omega-3 fatty acids, it's oil. So if it's under the triglyceride form or ethyl ester form, you need to first emulsify those fatty acids in order to be able to break them down because they're super large molecule and you can't just absorb them like that. You got to break them down. And that's what your enzymes that are part of your digestive system will do. So they'll come and they'll just break down those triglyceride fatty acids into free fatty acids and monoglyceride omega-3s or fatty acids that you can then absorb. Those are small enough molecules to be absorbed in your body. So by giving monoglyceride omega-3 in a soft gel and giving it to patients, you don't need to emulsify them. You don't need to break them down because they're already self-emulsified and they're already pre-digested in a way, right? They're readily absorbable. So they'll basically bypass the whole digestive system, which is pretty cool when you think of it. I mean, you don't need to emulsify them. They'll integrate your gastric fluids and your intestinal fluid. Then they'll just go right through in your blood. They'll be readily absorbable because they're already digested. So even if you have problem producing bile, for instance, or you have problem producing enzymes, those monoglyceride omega-3s will just, bypass the whole system and just readily be absorbed. So that's one of the great features of monoglyceride. One is the fact that it's self-emulsified, but also secondly is pre-digested, the fact that they're readily absorbable. So when you take them, they just bypass the whole digestive system and right through. So anybody that has malabsorption issues, could be disease-related, could be genetic. It could also be age-related, because as we grow older, we have a harder time producing that bile, producing those enzymes, processing all those fats in order to be able to absorb them. So it's a great solution for those types of issues.
In other words, if I hear what you're saying correctly, that it's more efficient because it's self-emulsified, it's more readily absorbed, it's more quickly absorbed, the benefits are there. It doesn't have to go through that same process of digestion.
Yeah, exactly. And Dr. Fortin proved the concepts, and other research teams as well proved the concept. Dr. Fortin proved it with the cystic fibrosis patient study, but we also had other groups look at patients that were given orlistat. It's a drug that prevents the production of enzymes. So even in those conditions, the monoglyceride omega-3s were still being absorbed. So that was the proof of concept that you don't need to emulsify the fatty acid and you don't need to digest them. It'll be readily absorbed, where for those patients, if we were giving them triglyceride-based fatty acids, they weren't able to properly absorb them. So the absorption efficiency of MAG-O3 was much greater when compared to regular fish oils or fatty acids. So that's the first set of studies that Dr. Fortin and other groups conducted. And then the second set was to compare it with a healthy population group, where Dr. Fortin compared ethyl esters, triglycerides, reesterified triglycerides with the MAG-O3. And for those healthy populations, for those studies, MAG-O3 always came on top. I think that for the pharmacokinetic studies that were conducted over 24 hours, we saw that monoglyceride omega-3 rich MAG-O3 oils were 3 times better absorbed than a regular ethyl ester oil. And I think it was close to 2 times when compared to an RTG or reesterified triglyceride fish oil. Those are all studies that were conducted in the last 5 to 10 years that first proved that you don't need to be able to digest. Even if you can digest your omega-3s, you'll be able to absorb them if they're in the monoglyceride form. And then we compared to with a healthy population, even if you're healthy and you're able to properly digest, you'll still reap the benefits. You'll still be able to absorb more EPA-DHA when taken under MAG-O3 versus other regular oil. And then the other part, Mike, is what's really interesting is the fact that it's self-emulsified, that it's an emulsifier. It now becomes a delivery system for other liposoluble nutrients. So if let's say you take vitamin D or vitamin K, for instance, which is one of the molecules that we looked at, we've actually combined K2 with MAG-O3, and we were able to show that the presence of monoglyceride omega-3 facilitated the integration of vitamin K2 in your digestive system and increased its absorption versus if it was mixed with a regular fish oil. So we put vitamin K2 with ethyl ester fish oils, vitamin K2 with reesterified triglyceride, and with MAG-O3. And we were able to show that when it's combined with MAG-O3, you get 10 times the absorption versus if it's combined with a regular fish oil. So it really acts also now as a delivery system. As much as it does for a regular omega-3, it actually helps the integration and absorption of other liposoluble molecules, which would be combined with our MAG-O3. So it's a nutraceutical, natural delivery system.
I know that this differs greatly because of this technology, because of the research and how this was put together, than a lot of what's available out there in that buffet of choices of supplements that have krill or other fish oil sources. So definitely you're at the cutting edge here in terms of this being not just an omega-3 option, but a solution for those who maybe haven't gotten the results they were looking for in taking omega-3 supplements before.
So first of all, for inflammation, EPA is the fatty acid that you want to concentrate on because the ratio arachidonic acid EPA, it's the two, fatty acid with 20 carbon on it. It's very similar molecule. One is an omega-6, the other one is the omega-3. It's the substrate for the same enzyme on the inflammation cascade. So when there's inflammation, usually the arachidonic acid get metabolized to PGE2 or other mediator that trigger the inflammation. At the same time, the same enzyme metabolize the EPA to form inflammation resolution molecule. It's not an anti-inflammatory. It's inflammatory resolution. So at the same time that the body create the molecule that trigger the inflammation, and the other one that maybe a couple of hours later or a day later will just shut down the inflammation. It's like the gas pedal on the car and the brake. You have to have both. You do need the inflammation. You do need the arachidonic acid. But without any EPA, it's inflammation all the way, and there is no resolution. So it's when the inflammation goes chronic that you cannot repair or diminish the inflammation with the EPA. So you have to have a balance between arachidonic acid and EPA to make sure that your body can trigger the inflammation and resolution of the inflammation. So omega-3, it's not an anti-inflammatory, it's a resolution of inflammation. You do need the inflammation. And that's why EPA is the one you need in your cells, both with arachidonic acid. And that's why the ratio arachidonic acid EPA, it's one biomarker of inflammation. If you have too much arachidonic acid, not enough EPA, at the time you get inflammation, you're hurting yourself, or you got a cold, flu, everything, you go with inflammation all the way, and there is no molecule to cool down the inflammation. You need EPA if you want to control your inflammation.
This is game-changing. It's revolutionary for practitioners to understand that it's about metabolism of these oils and that inflammation is not the bad guy. We've often looked at, okay, what's the best anti-inflammatory solution? And what you've been able to identify is that inflammation is a healthy process that the body undergoes at an ongoing basis. The trick then is to balance inflammation rather than to do away with, or let's find, the best process to develop with anti-inflammation. It's not about an anti-inflammatory process as much as it is helping the body to undergo a healthy balance of inflammation and resolving that. Am I understanding that correctly?
Totally, because, for example, if you take too much classic anti-inflammatory, like cortisone or something like this, you're prone to get whatever, the cold, the flu, and everything, because your immune system needs this inflammation. It's a signal that something's going wrong. You have to keep this signal. You have to have this reaction, but you do need omega-3, especially EPA, to cool down the inflammation after, the aggression is past. And the problem right now is the inflammation is going chronic with so much people that they are always on inflammation, always, and it's not good. You have to have the episode of inflammation when you need it, but after this, you have to cool down the inflammation with resolution. And the EPA, it's the molecule to have without too much strong antioxidant. And MAG-O3, it's the best formulation we have right now. And we tested this same formulation that actually being tested on a clinical trial. It's exactly the same that we have at EB Supplement. So it's a real world tested omega-3 formulation, and it's the same that I put on my cancer cells, always the same, and it's worked. So
could you delve a little deeper into, you mentioned this earlier, apoptosis, and how MAG-O3 affects apoptosis activity in cancer cells?
Yes. I love apoptosis. It's a wonderful process. It's a process when a cell need to shut down himself. It's like doing harakiri. So the cells, it's bad, it's damaged or something, and there's a signal pathway inside the cell say, okay, it's time to recycle. So the cell is undergoing apoptosis. So there's a lot of molecules that are liberated on the cells to just cut it down in small pieces. And all the small pieces are recycled to make new cells. But this process to induce apoptosis, it's the mitochondrial pathway of apoptosis. So basically, the cells on the mitochondria, they have a cytochrome C inside the mitochondria. Mitochondria, it's like a bacteria in our cell. The mitochondria have another membrane. So it's an organelle inside the cells that have their own barrier. It's the power plant of the cells. So it's where all the energy, the ATP is formed. So there's a lot of oxidation on the mitochondria, and the membrane of the mitochondria, it's rich in omega-3 fatty acid. And you need this omega-3 fatty acid because when the signal of the apoptosis is triggered, the mechanism is to oxidize the EPA, DHA, and DPA, the long-chain omega-3 fatty acid in the mitochondrial membrane in a specific lipid called cardiolipins. So it's a kind of lipid it's just found in mitochondria. And this oxidation of this lipid create a pore, like a hole on the mitochondria, and the cytochrome C can go from inside the mitochondria to outside the mitochondria in the cells. And it is the presence of the cytochrome C in the cells that causes apoptosis. So you need omega-3 on the mitochondrial membrane to make this hole in the mitochondria. If you have not enough omega-3 in your diet, you will have less omega-3 in your mitochondrial membrane, and you will need a stronger signal to induce the hole in the mitochondria. So by putting more EPA and DHA in your diet, you enrich your mitochondrial membrane, and you decrease the energy level needed to trigger the apoptosis. In some cancer cells, they avoid apoptosis because there's not much omega-3 on the mitochondria. So one of our theory is the mechanism of action of the omega-3 fatty acid on apoptosis. It's to enrich the membrane of the mitochondria. And when the signal of apoptosis is triggered, it goes apoptosis right away. There is no barrier because there's plenty of omega-3 fatty acid on the membrane, on the cardiolipin, to be oxidized, to form the pore, to allow this cytochrome C to go in the cells and induce apoptosis. So it's simple. You need omega-3 on your membrane and your mitochondrial membrane.
So despite the B vitamins, the ribose, the carnitine, or whatever, other compounds that are supposedly there to help with mitochondrial biogenesis, it's critical, or it's essential, as you're saying, that we nourish the cell membrane, the mitochondria cell membrane, with the appropriate oils.
Yeah, you have to keep your membrane fluid. So EPA, another thing of the EPA and DHA, it's keep all the membrane so fluid that all the complex of the mitochondria can be a little bit tighter, and we got this efficiency, and we prove it on the fruit fly. So basically, we fed fruit fly with EPA and DHA in 2 different diets, and we isolated mitochondria on the fruit fly, and we saw and we measured the dynamic of the mitochondria, and we proved that we increase the efficacy of the mitochondria. So less radical form for the same amount of ATP that it's formed. So the mitochondria, the membrane, it's so fluid that all the complex on the electron transfer chain are tight, and there's less loss and more efficient. So we got a more efficient mitochondria. And at the end of the experiment, we increased the lifespan of the fruit fly by 20%. So good mitochondria, you have an increase in longevity because the energy making process, it's more efficient. There's less waste, less radical, less bad molecule that can cause DNA damage. So your mitochondria, it's more efficient. And if something goes wrong, it's ready to induce apoptosis. So you need omega-3, a lot of omega-3 in your mitochondrial membrane.
I think it's been underutilized. Omega-3s have, and now that they have this ideal option to be used right out of the gate in every protocol now, as I understand this. I'm glad you've addressed this about the mitochondria, because practitioners often look at as month 1 of a 3-month or a 6-month protocol for their patient with these gut ailments or with this neurotoxicity or whatever they're trying to help their patient with. As month 1, mitochondria is a front runner for many of them. Let's focus on that. Let's really help take care of the mitochondria in the cell so that this process can become more efficient. And if we're incorporating in what you're saying with MAG-O3, it could be game changing. It could really make a substantial difference. And not to mention the sustained energy levels that patients or clients will experience because they have taken MAG-O3, not just the other nutraceuticals that also can influence mitochondrial biogenesis, but omega-3s, which are paramount right out of the gate. This is no longer, like I've stated earlier, this is no longer just about helping with heart health, cardiovascular health. This goes way beyond that.